Example number 4. Now, example number 4 says, prove that tan squared theta minus sine squared theta is equals to tan squared theta sine squared theta. Right? Now, when you are faced with a problem like this, you have the left hand side and the right hand side. So this is the left hand side and then this is the right hand side. The first thing that you need to do is you need to simplify the left hand side. If it's not the same as the right hand side, therefore that is when you will simplify the right hand side. Okay, now let's start with the left hand side. So on the left hand side, right, what do we have? We have tan squared theta sine squared theta. All right, now you have tan. Remember, when you have tan, what do? You simplify it by sine theta and cos theta. So this is how you'll write it: sine theta cos theta. Okay, so this will be sine squared theta. All right, so this will be simplified as sine squared theta cos squared theta minus sine squared theta. You get that? Now, what do we need from here? What we need is the LCD, lowest common denominator. All right, what do I have here? I have 1, right? So this is how you go about it. You will multiply this sine squared theta with that denominator right there. Okay, and then what you'll have is sine squared theta, because it's multiplied by 1, then minus this minus. Okay, now you need to multiply this with that denominator. Okay, so what you'll have is sine squared theta cos squared theta, then divide by, right, cos squared theta, because this denominator will multiply that. So cos squared theta multiplied by 1 is cos squared theta, right? Doesn't change. Okay, what do we have? What we can do here is to simplify. All right, so we can simplify because we have like terms. Like terms is sine squared theta and sine squared theta on both sides. Now, what I'll do is say sine squared theta, right? So I'll have 1 here because I removed sine squared theta this side, right? So I'll have minus there, and if I remove sine theta here, I'll be left with cos squared theta. So cos squared theta. This is how you simplify that part. Okay, so this is factorized. Okay, then you have cos squared theta. All right, so 2 things right here to note. We have sine squared theta, right, over cos squared theta, which can be equivalent to tan, right? So I'm going to write that as tan. Okay, so I'm going to write it as tan theta, tan squared theta. So this is what I have, that part. That part right there is tan squared theta. All right, therefore you are left with 1 minus cos squared theta, right? This, right, remember the Pythagorean identity, right? So this is sine squared theta, which is 1 minus cos squared theta, right? So what I'll do here is I'll write tan squared theta, right? Now, to replace the whole thing right here, right? I'll replace it with what I have here, sine squared theta, because sine squared theta is equals to 1 minus cos squared theta, which is what I have right here, right? So I'm going to replace it with sine squared theta. This is what I have on the left hand side, right? Now, you compare what you have on the left hand side, the simplified version. Is it the same as what you have on the right hand side? Yes. So if these two are the same, then you have answered the question. Example number 5. Right. We need to prove that the left hand side is equals to the right hand side. Okay? It is very important to note that on the left hand side, the numerator is similar to having 2x squared plus x minus 1, right? Meaning that in place of cos, I put x, right? Just to explain what this is. Now, the question that you need to ask yourself is, can you factorize this expression, right? Let's find out. I'll have 2x, x, 1, 1. So positive this side, negative, right? Now, when you break it down further, 2x will multiply x, and then 2x will also multiply positive 1. All right? Now, minus 1 will multiply x, and minus 1 will multiply 1. Right? Let's do that. So 2x multiplied by x, that will be 2x squared. And then 2x multiplied by positive 1, that will be positive 2x. All right? Now, what do you have? Minus 1 multiplied by x, that is minus x. And then the last one, minus 1 multiplied by positive 1, that is minus 1. Minus 1. Now, these two right here, right? These are like terms. 2x minus x, that is x, right? The answer is x. So then we have the rest of the expression like that. Now, when you look at this, right? This is exactly the same as what we had right there. That means this expression can be factorized, right? Now, this is nothing different from this, right? What I'm going to do is I'm going to factorize the numerator in that format, right? Meaning that in place of x, I am going to put cos. Let's do it. So 2 cos theta minus 1 cos theta plus 1. You understand? And then I write my denominator as sine cos minus sine theta, right? Now, in the denominator, right, what do we have? We have like terms. What are like terms? Sine theta and sine theta are like terms, right? Now, if you factorize, right, you remove this on this side, you'll be left with 2 and cos. And After the minus sign, you'll only be left with 1. All right, so let's do that. I'm going to rewrite the numerator like that, and then take sine theta as a common factor. Then I'll be left with 2 cos theta minus 1. All right, now look at this. 2 cos theta minus 1 is the same as 2 cos theta minus 1 here. That means these two can cancel each other, right? What am I going to be left with? I'm only going to be left with cos theta plus 1 in the numerator, and in the denominator sine theta. Right, now look at this, right? If you have 1 plus 2, right? This is the same as 2 plus 1, right? Because the answer will be 3 in both scenarios, right? When you have cos theta plus 1, that is the same as 1 plus cos theta, right? So I'm going to rewrite my answer. So in that format, I would have 1 plus cos theta sine theta. Look at that. This is the answer that I got on the left-hand side, right? Is it the same as what we have here on the right-hand side? Yes, that is exactly the same. Therefore, I've answered the question. Example number 6. We need to prove for example number 6 that the left-hand side is equals to the right-hand side, right? Now, before we continue, I want to mention something about the left-hand side of the previous example, example number 5. Now, this is the left-hand side from the previous example, right? Similarities. There is 1 right here, and there is 1 over there. Okay? Now, the difference. This one could be factorized. All right? So we managed to factorize this expression, but this one right here cannot be factorized, right? That is the difference. But the similarities is that they both have 1 in their expression. All right? Now, when you have an expression and there is 1, and you can factorize, or it's possible for you to factorize, please go ahead by all means and factorize that expression. Right. Now, what happens in an event where you have an expression, you have 1, but you cannot factorize? Right? Let's find out. So this is the left hand side. Okay, I'm going to rewrite the left hand side. 1 minus 2 sine theta cos theta sine squared theta minus cos squared theta. Right? Do you remember something like this? Sine squared theta plus cos squared theta is equals to 1. Do you remember this? Tell me what this is. This is the identity, the trigonometric identity, right? Now, this is where it comes in. When you have an expression and there is 1 right there, right? And you cannot factorize that expression, you need to introduce the trigonometric identity. But if you have an expression and there is 1, but you can factorize, there is no need to introduce the trigonometric identity. You can only introduce it when you cannot factorize and there is 1. Right. Now, going forward, where you see 1, you need to put the identity. Sine squared theta plus cos squared theta, right? And then write the rest of the expression as it was before. Minus 2 sine theta cos theta. Now, in the denominator, right, what do we have? We have sine squared theta minus cos squared theta. This is the same as x squared minus y squared, right? How do you factorize this? This is how you can go about it. X, y, minus and plus, right? The difference of two squares, okay? So when you simplify, this will be x squared minus xy plus xy minus y squared. So these two will cancel each other and you'll be left with x squared minus xy minus y squared. Okay, so this is exactly the same as the one that we've been given. That means we managed to factorize it the right way. Okay, so when you have something like this, you can rewrite it to be like that. So it's nothing different. In the denominator, this is what I have. I'm going to factorize it and rewrite it like that. Okay, so what do we have? We have sine theta minus cos theta, and then we have sine theta plus, you see here we have plus cos theta. All right, so I'm just going to remove this to create space. All right, now let's continue. What I'm going to do is I'm going to rewrite my numerator, right, in order. So sine squared theta minus 2 sine theta cos theta plus cos squared theta, right? Divide by my denominator as it is. All right, now look at this. The numerator, right, is the same as x squared minus 2xy plus y squared. All right, so when you have this, how would you go about it and factorize? So I'll have something like this: x y minus, right? And then this will be x minus y squared because they are the same, right? Now what I'll do here is that I am going to rewrite my numerator in this form, right? Let's see. So the numerator will be sine theta minus cos theta squared, right, divide by sine theta minus cos theta sine theta plus cos theta. Let's remove this part. All right, now what do I have? I have similarities. So sine minus cos, right? And sine minus cos. What I'll do is this will cancel the one below, right? So it's exactly something like this, similar to something like this. If you have x squared over x, right? So your answer will be x, right? Now, what do I have here? So this side I have sine theta minus cos theta squared divided by sine theta minus cos. So the contents inside the brackets are the same, right? So it's similar like what I have here. So the answer will be in the numerator sine theta minus cos theta, right? So what I'll have here is sine theta minus cos theta in the numerator, and in the denominator I'll be left with sine theta plus cos theta, right? So this will be my simplified answer. Now the big question, is this answer on the left hand side similar or the same as the one on the right hand side? Yes, they are the same, right? That means you managed to answer your question.